Cephalosporins are a class of antibacterial drugs. Like penicillin, they work by preventing the cross-linking of bacterial cell walls. In this visual mnemonic video, we're going to give you an overview of cephalosporins and how they work in preparation for dedicated videos on each of the 5 generations of cephalosporin drugs to follow. Things are getting heated in the kitchen today. This strict, experienced master chef is looking extremely displeased with her trainees' culinary skills. No way is she going to let them serve food in her kitchen. By the way, this chef is our symbol for cephalosporins. Get it? You could even call these chefalosporins. These drugs are antibiotics that work similarly to penicillin. Let's explore our scene to learn more. Our master chef is recording grades for these trainees on a notebook. To make sure she always has something to write with, she attached a pencil to the notebook using this black pencil ring. This black pencil ring is our recurring symbol for the beta-lactam ring. Get it? Black ring for beta-lactam ring? You could even call it a blactam ring. We're talking about a beta-lactam ring because cephalosporins are beta-lactam antibiotics. To understand how these drugs work, let's quickly review the D-ALA-D-ALA sequence in bacteria. D-ALA-D-ALA is essentially a sequence of amino acids that forms the ends of the building blocks of the bacterial cell wall. These building blocks are normally glued together by bacterial transpeptidase enzymes, which connect a D-ALA-D-ALA terminal sequence to the next building block. This process is known as cross-linking and helps to maintain the bacterial cell wall. Like penicillins and other beta-lactam drugs, cephalosporins act as D-ALA-D-ALA analogs, which means that they mimic the D-ALA-D-ALA sequence. Cephalosporins therefore compete with these building blocks for transpeptidase, blocking the enzyme's activity. Through this mechanism, cephalosporins prevent the cross-linking of the bacterial cell wall, thereby killing the bacteria. Our chef is so angry with her trainees' incompetence that she's smashing down with her pencil onto her grading notepad. Any other pencil might have broken, but since this mechanical pencil is made out of metal, it's pretty resistant to breaking. This sturdy, resistant pencil can help you remember that cephalosporins are resistant to penicillinase. Penicillinase is an enzyme produced by some bacteria that cleaves the beta-lactam rings of penicillin, inactivating the drug. However, most cephalosporins are resistant to the penicillinase enzymes by way of chemical modifications that prevent penicillinase from accessing the beta-lactam ring in the drug. Therefore, cephalosporins can be used against penicillin-resistant bacterial strains. It's worth noting that despite this resistance to penicillinase, bacterial resistance to cephalosporins can still occur. For example, mutations in bacterial transpeptidases can prevent the cephalosporin beta-lactam from binding. Secondly, some bacteria can produce cephalosporinases as a form of resistance to cephalosporins. These enzymes cleave the beta-lactam rings of cephalosporin, inactivating the drug. Now that we've learned about the mechanism of cephalosporins, let's move on to some adverse side effects. Let's turn over to our hopeless trainees. It looks like they've been trying to make a tomato sauce. But this trainee here is covered in red, blotchy hives. He must be allergic to the tomatoes he's handling. Let this trainee's hives remind you that cephalosporins can cause a hypersensitivity reaction. These symptoms can range from skin rashes to life-threatening anaphylaxis. You may know that allergic reactions are also a common side effect of the penicillin antibiotics. However, even though these two classes of antibiotics are both beta-lactam antibiotics, there is actually a very low rate of cross-allergenicity between cephalosporins and penicillins. That is to say, patients who are allergic to penicillin are not usually allergic to cephalosporins. Still, allergic reactions to cephalosporins are seen, so just remember this trainee's allergies to the tomatoes here, okay? Our trainee here is sneezing violently from his allergies. He sneezed so hard that he accidentally dropped his tray of tomatoes, which fell down and splattered on the table. By the way, these red tomatoes sure remind me of the color and shape of red blood cells. Then, the splattered tomatoes here can help you remember hemolytic anemia, or anemia caused by the destruction of red blood cells. You see, cephalosporins can cause the body to create autoantibodies directed against the body's red blood cells. As red blood cells are destroyed faster than they are created, this develops into autoimmune hemolytic anemia. Our second trainee is worse than the first. He was out late partying last night, and it looks like he's still drunk today. You can tell by his half-empty beer bottle and still flushed face. This red-faced trainee with a beer can help you remember that cephalosporins can cause a disulfiram-like reaction to alcohol. Because the red face of the trainee resembles the skin flush associated with a disulfiram reaction, right? Cephalosporins block an enzyme responsible for metabolizing alcohol, acetaldehyde dehydrogenase. As a result, the buildup of toxic metabolites of alcohol can cause nausea, vomiting, elevated heart rates, and flushing of the skin. Overall, this means that when patients are taking cephalosporins, they shouldn't drink alcohol. Next, notice how our drunk trainee is quite clumsy in the kitchen. He accidentally knocked over some Special K cereal boxes, adding to the mess in the kitchen. This Special K cereal is our symbol for vitamin K. You know, K for vitamin K. Then, this falling Special K cereal can help you remember that cephalosporins cause a vitamin K deficiency. You see, cephalosporins block the enzyme that activates vitamin K, known as vitamin K epoxide reductase. This is particularly important because vitamin K plays an essential role in formation of blood clotting factors. By preventing activation of vitamin K, cephalosporins lead to a decrease in clotting factors. As a result, bleeding can be a very serious side effect seen in patients taking cephalosporins. All right, we're all finished with our overview of cephalosporins. Let's do a quick recap before we go. Cephalosporins are a class of antibiotics used to treat a variety of bacterial infections. Like penicillins, these drugs are beta-lactam antibiotics. They are D-ala-D-ala analogs that bind to and block the bacterial transpeptidase, thereby preventing the cross-linking of the bacterial cell wall. Cephalosporins are also resistant to penicillinase, a bacterial enzyme that can deactivate penicillins by cleaving the beta-lactam ring. Because of this, many cephalosporins can be used to treat penicillin-resistant bacteria. However, cephalosporins also have a host of their own side effects. Firstly, patients may develop an allergic reaction after taking cephalosporins, which usually manifests as a rash. Taking cephalosporins can also lead to creation of autoantibodies that cause hemolytic anemia. Finally, a disulfiram-like reaction to alcohol and vitamin K deficiency are important side effects seen with taking cephalosporins. Okay, now we're actually done. These trainees still have a lot to learn. Let's leave this master chef to her training and get out of here. I'll see you in the next video.